Hi, greeting to you. We are from SIIPStea Group. In this video, we will present our BRELL project. Introduction.
I want to talk about background regular umbrella. Firstly, heat trap effect. Regular umbrella can make a person feel warmer due to their canopy acting like a heat trap, adding to discomfort on hot day. Secondly is additional burden. Carrying an umbrella on a hot day feel like an extra load, especially when juggling drinks, bag, and other items. Thirdly is wind instability. Regular umbrellas are not designed for windy conditions and can become unstable, tipping over or even breaking in strong wind. Lastly is better alternative for hot weather. Choose specially designed umbrellas that offer improved cooling and comfort for both hot and windy conditions. From the search, I identified several patterns that are relevant to our project. One of the most notable examples is pattern US 51727111A titled Combination Canopy and Fan. Let me take a moment to highlight pattern US 51727111A. This pattern describes a collapsible canopy integrated with a fan assembly, which rotates easily to enhance functionality. It was built in 1991 by inventor Anna Muller and James Morris. Although this concept is innovative, it lacks modern features such as smart technology or sustainable energy components, which are opportunities for improvement in our design. Firstly is strength. This pattern integrates two functionalities, shade and airflow. Secondly is weakness. This design is outdated, lacking modern material and energy-efficient technology. Thirdly is opportunities. By addressing this gap, we can enhance usability through renewable energy source.
Problem statement. Keeping people protected from the sun is one thing, but have they considered how hot the surrounding temperatures are even with the usage of umbrella? The air inside the umbrella are trapped whenever people use it for a long time on a hot weather, and eventually they will feel the hotness from it. Umbrella indeed protect people from the sun, but the body temperature will still remain the same, and if users are lucky to feel a breeze, it's sometimes lowered down a bit. This also sparked a what-if thought, where what if users are in a tropical country where the sun felt much closer and the rain felt much heavier. Sun can be deadly in this condition, especially from noon to the afternoon. Not only the users need to protect themselves from the sun, but they need to protect themselves from the heavy rain. Even if people using umbrella to cover themselves, there will always be the chances for them to be wet. Users will feel uncomfortable with how wet they are.
Hello, let me introduce you to our cause and effect change analysis, or known as CIIPStea. Here, our CIIPStea diagram. I assume you have encountered a scenario in which you feel uncomfortable when using an umbrella. In sweltering heat, there are a number of reasons why the heat beneath the umbrella is too intense. As you can see on our diagram, temperature rises caused by trip heat. Why? It is because of no ventilation for the air to escape. Then the reason for this cause, lack of airflow, where potential actual root caused by heavy fabric and simple design.
The functional analysis process consists of three key stages: component analysis, interaction analysis, and function modeling. Component analysis. The first step of function analysis is component analysis according to Ahmad et al. In 2016. In this stage, the various components of the engineering system and its supersystem can be identified, illustrating how these components are interrelated and interdependent. A component is a distinct entity that constitutes a part of the engineering system. These elements consistently interact and affect one another, whether directly or indirectly, to sustain their function and the overall existence of the system, as stated by Dalhuizen in 2018. These are the list of components in and around the engineering system of an umbrella. They are outer canopy, inner canopy, shaft, handle, rib, runner, stretcher, open or close button, end tip, tie wrap, and umbrella panel. And for the list of the supersystem around the engineering system will be raindrops, sunlight, and wind.
Alright, now I'm going to present to you about the second step for the function analysis, which is interaction analysis. Interaction analysis is to identify how components interact with one another in the system. It is consists of software tools and methods designed to evaluate the quality of interaction between the user and augmented content. As you can see here, this is the interaction analysis of the component in the umbrella system. I'm going to explain one by one. For the handle, it holds shaft and its control open or close button. For the open or close button, it controls runner. Runner will move the structure. Structure hold in a canopy, and structure is also hold rib. For the shaft, it will hold both structure and runner. Rib will hold umbrella panel. Umbrella panel hold outer canopy. Inner canopy will hold outer canopy also. Tip will hold both rib and umbrella panel, and tip will hold umbrella panel and direct wrap umbrella panel. So this is the interaction between the component in the engineering system. Okay, now I'm going to continue to the function model. Function model is the last step for the function analysis. It aims to clarify and illustrate functional relationships. We can achieve this by identifying interaction among components, but it must be translated into action first. This is the function model of the umbrella system. Before that, I'm going to explain about the function evaluation for this function model. This is the function evaluation. There are four types of function evaluation. The first is useful normal. Next is useful insufficient. The third one is useful excessive. And the last one is harmful. We can differentiate this function by the arrow. For the useful normal, the arrow is the normal line. Insufficient have a dash line arrow. Excessive have a thick line arrow. Harmful is the curved red line. Let's go back to the function model. For this function model of the umbrella system, we can see most of the components have the useful normal function, which is handle, hold shaft, shaft, hold runner, shaft, hold structure, handle, control open or close button, open or close button, control runner, runner move structure, stretcher hold in the canopy, hold outer canopy. Structure is also hold rib, tip hold both rib and hold umbrella panel. Rib absorb sunlight, the super system, and then you can see and tip hold umbrella panel, the wrap umbrella panel. So, the function model of the umbrella system is consists of engineering system and also super system. Most of the function is useful normal. In this case, handle, hole shaft, shaft hole structure, shaft hole runner, handle control open or close button control runner, runner move structure, hole rib structure, hole in the canopy, hole outer canopy, tip, hole rib and hole umbrella panel. Rib also absorb sunlight. And tip, hole umbrella panel, direct wrap umbrella panel, and outer canopy protect person. This is all the useful normal function. In this function model, we can see that it also contains of the function insufficient, such as rib, hole umbrella panel. This is due to the strong wind. The rib does not have enough strength to hold the umbrella panel during the strong wind. This will also affect umbrella panel have insufficient function to protect the person. Next, we can see the outer canopy also have insufficient function to hold wind and hold raindrop due to the strong wind and heavy raindrops. Outer canopy also have useful excessive function, which is outer canopy block sunlight. This will affect the person who using the umbrella still feel hotter when using the umbrella. For this function model, there is no harmful function in this system.
For a number of reasons, we employ rule B for trimming. According to the diagram, a person must hold an umbrella to protect themselves from the intense sunlight and use a hand fan to cool the air beneath the umbrella. The image above, which shows how challenging it is for someone to simultaneously hold an umbrella and a hand fan. Our invention will eliminate the need for individuals to hold a fan in order to cool themselves from the heat. The umbrella itself will use some novel design and technology to provide a pleasant air.
Next, I'm gonna present about problem statement. Let's begin with the problem. If the umbrella should protect people from the sun, then the temperature underneath it should reduce. But the heat under the umbrella becomes more intense due to the limited airflow. This presents an engineering contradiction. One parameter improves, but another worsens. Contradiction metric. To resolve this contradiction, we use the contradiction matrix. Here the improving parameter is temperature reduction parameter 70, and the worsening parameter is heat intensity parameter 10. The matrix suggests three inventive principles. Number 1 is principle 3, local quality. Number 2 is principle 10, preliminary action. Number 3 is principle 35, parameter change. Inventive principle explained. Let's discuss how this principle can be applied to the resolve the contradiction. Principle 3. Local quality. Each part of the umbrella should operate optimally. For example, adding a fan to the umbrella improves airflow and enhances cooling efficiency, particularly in the canopy. Principle 10. Preliminary action. Prearrange system to handle the heat. A solar power fan under the umbrella can create airflow, reducing heat and making it more comfortable. Principle 35. Parameter change. Modified how heat is managed. For instance, using a cooling pad powered by a solar panel can improve airflow and and dissipate heat effectively. In conclusion, by using the contradiction matrix and effective principle, we can creatively solve engineering challenge. In this case, the umbrella not only reduced temperature but also addressed the heat build-up underneath it.
Function-oriented search. Initial problem. Feeling hot even with the usage of umbrella on a hot weather, making it lost its one of main purposes, cooling down body temperature. Precautions towards water during rainy days are considered since users still get wet even with the usage of umbrella. Function, regulating body temperature and drying. Key disadvantages. Adding more purpose to the umbrella besides protecting human from the rain and sun. And for that, it is important to considering the design of canopy where shape doesn't give much purpose and it is not systematic. While technology-wise, a need to have temperature control and drying purposes. Generalized function to make the users feel comfortable during hot weather by regulating their body temperature. Not only it can cooling down users' body temperature, it can also giving a drying purpose during rainy weather whenever they are wet. Leading industry areas. Protection. Possible technologies. Adding a flexible fan in the inner part of umbrella, creating a cooling system by changing the shape of the canopy. Adding solar panels for recharging of battery. Lease areas. Open outdoor spaces, buildings without roof. Chosen technology idea. Portable fan and modern fan.
Next, I will present about S-curve. The S-curve is a powerful tool that illustrates the life cycle of product of technology. It represents the phase of innovation, growth, maturity, and saturation. Understanding the S-curve. Let's analyze the S-curve graph. In the early phase, umbrellas were simple and traditional, offering basic protection like parasols. Progress was slow because the technology and market adoption were still developing. As innovation were introduced, such as automatic mechanism, lightweight material, and water-resistant fabric, the curve steepened. This marked a period of rapid growth and widespread adoption. This advancement addressed practical user needs, making umbrella more functional and accessible. Maturity and breakthrough. Eventually, as the market matured, the curve leveled off, showing diminishing returns from incremental improvements. At this point, traditional umbrella reached their peak functionality. However, the introduction to breakthrough innovation, such as umbrella with built-in fans or cooling mechanisms, sparked the beginning of a new S-curve. These breakthroughs address additional needs like cooling in the hot climates, creating fresh and demand and fueling renewed progress. In conclusion, the S-curve not only shows the evolution of umbrella technology, but also demonstrates the importance of innovation in driving growth and overcoming market situation, breakthrough features, and can redefine products, unlocking new potential for progress.
That's all from us. Thank you for your time.